I'm going to be sneezy today for some reason. My goodness. Okay. I'm back with a box of Kleenex, so hopefully that'll tide me through here. Where are we at? This is the time when we skip a bunch of stuff, right? We did our loops last time, for loops and while loops. Now we skip chapter 10, matrix operations. And we skip chapter 11, other types of arrays. I think we skip 11. Let's make sure we know what we're doing here. So we should be right about here. Yeah, so that's when we're supposed to do this week. But I'm actually going to change that assignment for week 10. I'll be putting in some actual problems to do because here we go. Yeah, so we just finished week 9. So week 10, week 11, week 12. We're skipping chapter 11, 10, 11, 12, which are all pretty much math things that we don't have the background for, and 13. All of these things are just a little bit beyond what we expect you to know when you start this class, so we really shouldn't get into it too much. And we will get to now chapter 14, which is images. So let's see which assignment that is and adjust it accordingly. That's week 11. Leave page. So this is actually, we need to actually, week 12. Okay. All right, so these last ones, week 10 is Week 10 is supposed to be the GUI assignment. Week 11 is actually, week 11, week 12, and final assignment are all part of the final project. So we need to add an assignment in here. What I will do is I'll just adjust some of these really quick. So week 11 we'll call week 12. And week 12 we'll call week 13. I revamped this class last year to make it a little simpler, and I'm always tweaking things here. So I'm going to tweak it again right now. So that's week 12, week 13 now, and then this one is final project. Fine. We'll submit that. Okay. Now we have room to fit in something here. We'll change this one to week 10 assignment GUIs, and that will be our chapter 15, I believe. Yeah, chapter 15. And chapter 16 goes back to math that we can't do, so that'll be week 10. And I think what I'm going to do is actually change these to chapter numbers, but we'll do that later. And we'll actually call this week 11, because we'll do that next week. I'm just going to change it to chapter 14. Okay, and then we'll change this. Well, no, we need to add a new one. So let's make a new one. Let's create a content. Let's create a, what am I creating? An assessment. Here we go. There we go. So, create an existing test. Name, chapter, yes, right. It's not supposed to be GUIs though, it's images. Alright. We'll put some questions in later. Let's create assessments, tools, trying to remember how to do this. All right, I'll have to remember how to put this new thing in here. It's been a while since I've done it, almost a year. But anyway, what we'll do with this is we'll add a new homework assignment in here for the images. It'll be chapter 13 assignment, images, or whatever this chapter 14 is called. Advanced graphics, it'll be advanced graphics. And we'll put that in there, we'll add it in, and we will and then we will have the assignment for this week. But this week we are going to talk about some advanced graphics. So chapter 14 in the book, page 543 it looks like. And let's get going. So of course we've made plots already. We've even animated some plots and other things like that. Made some nice designs using MATLAB. We've learned the basics of how that goes, and that's good. I'm not going to go into a lot of detail about that stuff that we've already done. What we want to do though is look at images that MATLAB can evaluate. So an image to a computer is nothing more than a file. It's just a file of numbers, and it's actually an array of numbers. The numbers tell you different information. They tell the computer what size the picture is, first of all. Tell you its resolution. It tells you what colors to put in what pixels, in what positions. Can tell you brightness of pixels, and so on and so forth. So it's really just a set of instructions telling the computer what to display on the screen or print out on a printer or whatever else. And it turns out that MATLAB can read three different kinds of images. One of them is called intensity image, which is kind of black and white grayscale image, an indexed image, and an RGB, or a true color image. And this covers a lot of the images that you've ever encountered on a computer. So let's take a look at a type of intensity grayscale image that MATLAB actually has stored for demonstration purposes. It's called spine, so I'm going to load this thing in. And now it is, when we told it to load spine, it loaded three different things into our workspace. It loaded a caption. If we open up the caption, it tells us what would be in the caption. In this case, there's nothing in the caption. We can put it in if we want to. We can put some text in that caption, for example. So that's the caption file. Then it opens the map file. The map file sets up the image surface and space where the image will go. And then this X file, which has a whole bunch, oh, this one actually sets up the image space now that I'm looking at it. This one tells us how big the image is going to be. The other one tells us the actual pixels in the different pixels. So anyway, in the end, you can actually see it. We're going to use a function built into MATLAB called image. I don't remember this, but anyway, it's capital X is this thing, so we have to use a capital X. We'll hit return, and it's actually going to bring it up. Now, in this case, it brings it up in a certain type of grayscale. This is not a color picture that was taken with a color camera. This is a grayscale image, but it's been shaded in a particular spectrum because MATLAB uses a standard shading protocol. And you can change that shading protocol depending on what you choose. You can choose different shading protocols. For example, this, and they call that a color map. So in this color map, we're using the jet. This is called the jet color map. They just give them names for whatever else. We can actually change the color map to bone. So we do color map, bone, and we'll do this again. Oops. Just go back to here and change to color map bone now. Let's see if we can get it done. And go back to our image, which is hanging out over here. And when it goes to color map bone, it goes to a more standard black and white kind of image that you're used to seeing in X-rays and whatever else. So that's the bone color map. And there are other color maps that are out there. They actually have a color map called map, actually. Take a look at that one. So that one's slightly different, not a lot different. But you can actually also dock the images. So to dock the image, to put it into what your normal window is for MATLAB, use this little arrow up here, and it'll put it into your MATLAB windows. I like to have it over here personally. I like to have it kind of in this space over here somewhere, so I can still have my command window and stuff over here. But that way you don't have to keep jumping around your screen all the time. But anyway, this is just an image that, and you can do this with all kinds of images. Images that you have on your computer, images you download from the internet, all kinds of other ones. And there are other images that are stored in MATLAB as well. Another one that is stored in MATLAB is an image called Mimas. If I load Mimas, it's a moon. Which is it? Jupiter or Saturn? I don't remember where this. Oh, it's not in there. Is that a spell right? Oh yeah, we do. Yeah. Load. This image is a JPEG image, so you have to give it the entire file name. Oh, it's still not bringing it up. We can go grab it off the internet though. I'm going to actually take a little bit of a break here. I'll be right back. I'm not feeling very well, so I'll be right back. Sorry about that. Oh. Okay. Just can't seem to keep food down. Okay, so images, back to images. So essentially what it comes down to is that you can pretty much import any kind of image into MATLAB. But what MATLAB is going to see is it's going to see a series of files that tell the computer what to do to make that image. Whereas your normal computer just opens the image and that's what it does. MATLAB is going to see the files, the data that makes the image, and then you're able to do what you want with those files. Either you display the image, or you can actually start to manipulate it. You'll notice that when this figure opened up, if I want to take this out of the dock, I come up here and I go to undock. So I take it out of the dock. When this image first came up, it looked kind of like this, and I'm changing the perspectives of it here as I move the window. But MATLAB has chosen a default size for this image to fit into, kind of a default palette or window that it's going to map it onto. But you can actually specify what size you want it to be. The default is the default, but if you specify what you want it to be, then you have to use some commands in MATLAB. So let's take a look at some of these commands. I'm going to try to get through this stuff as quickly as possible in case I get sick again. That won't be very fun. Okay. Oh. All right, so let's actually bring in another file here. Actually, before we do that, let's go do some things here really quick. First, let's look at the imgesc function. Let's learn some more about that one. That's the one we used to display the image. So this is the image scale data and display as image. So it's called scale data and display as image. What it does is it takes the data, the image data that I've got over here in my workspace, and creates the image from it and then displays it. And then you can specify scaling within this as well. So that's the one thing. The other thing that we used so far is the color map. So let's go ahead and help color map and see the different kinds of color maps that are available. So here's the color map function. It sets the properties of the color map that you're going to use, whatever one you're going to use. Then you've got lots of different ways you can do it, I guess. There's default also, which we've seen already. They don't tell you all the different color maps, unfortunately, but so anyway, those are the two that we've used so far. I just wanted to see what else we could learn about them really quick. Don't want to go into too much detail. There's a gray color map. I think there's a green. There's a red. But anyway, just different color maps. You can get more information otherwise. But let's take a look at. Let's actually not try to find. Well, let's bring something on. Let's bring something from the internet. Let's go to the internet and let's search for a file. Let's look for a file of Saturn. I like Saturn. Oh, this is a really good one here at NASA. Like that one. So let's go ahead and let's download this image. Save image as. Go ahead and save it as Saturn.jpg. We'll put it in my pictures, make it easier to find. And we will save it like that. Then we're back to MATLAB, and we're going to load Saturn.jpg. Let's see what it does for us. I'm unable to read this because there's no file or directory. Remember, when you're in MATLAB, it only looks for things that are in your current folder that you're in. The current folder that I'm in is a MATLAB folder. Users, it's under Users, Jared Daily Documents, MATLAB. So I have to put that picture in that set of folders in order for it to see it. That's something that's easy to forget. So let's go do that. Let's go look at my pictures really quick. And there's Saturn. It needs to go under Users, Jared Daily Documents. So I'm going to put it under Documents. Then I'm going to open up my Documents, and here's my Saturn. Here's my MATLAB folder in Documents. So I put my Saturn in there. And now it should show up in this folder. So I should be able to load this now. Let's take a look. Load Saturn.jpg. Now it loads it because it knows where it is. So it's brought up this little file called Saturn. So now I've loaded this in here. I need to use the same set of commands that I did before. If you look back on after I loaded the spine image, I need to use a command to actually show the image. So let's do image. I think this will work. No, let's try it with X in there. I think it may have replaced my capital X. Let's check to see if it did. Oh, because I didn't look at my thing yet here. Let's take a look. Nope, it didn't put it in there. So we're going to have to actually this is a different one because when you have okay, so this has to be done differently because when it brought in the Saturn thing, let's take a look at this. It brought in essentially it opened up a empty matrix here because the JPEG image needs to be brought into something that it can read. So MATLAB knows what it is, but it needs to know how to read it. So we have to actually use this. There's a thing called image read, IMREAD. So what this is going to do is it's going to take the image, JPEG image, that is the Saturn image, and it's going to put it into the file that I tell it to put it into. I'm going to put it into X again. Actually, I'm going to put it into Y, capital Y. So this is going to make a matrix of all the information needed for displaying this image, a matrix for all the information needed, knowing where all the pixels are and everything else, then we can start to manipulate it. Oh, I don't have it defined, so I have to put it into X since X is already defined. Oh, come on, give me a break. X equals imagery. Oh, sorry, I did that wrong. X equals image read Saturn. That's what I need to do. I need to put the name of the file on here, not the name of the... And I need to put it in Saturn.jpg, and I need to put that in quotes so it knows that that's the name of the file, the string. And I'll make this equal to Y. Then I'll define it. Then I'll be ready to go. So there it is. And I didn't suppress it, but this is all the data from that image. So here it is showing you some different, this is actually parts of the image that you're seeing here. These numbers in the middle would be parts of the image. So anyway, now we should be able to do something with this. Now we should be able to actually display the image, read this file and make it into an image. So we'll do, what's that one? Image, let's see. We should be able to do that for Y. And there's our Saturn image. Comes up in MATLAB. And then of course you can change the color map and do other things like this all you want. So when it comes in as a JPEG, first you have to convert it into the number file. You have to read it into a number file that MATLAB can work with. It's essentially just a matrix. You have to put it into a matrix. And then you can do the same stuff with it as before. We could do a jet color map if you wanted to. Or red color map. Let's do a red one. I think red is one of them. Color map red. Yeah, color map red. Let's try that. No. Let's just do color map jet. That's the one I know. And let's take a look at our image. What has it done to my image? Not much. How come it's not affecting my image? It should. Oh, I must be doing something wrong. Let's do color map gray. Still not affecting it. Why is it not affecting it? Oh. I don't know why it's not affecting it. It should affect it. See if I put them on the same line and execute them. I don't think it'll let me do this. No, it won't let me do it. Only if I do the new file. But anyway, I actually want to move on because manipulating the images like this is fun, but not really what we want to get into today. There's another way to import stuff in MATLAB, of course, which we've already done before with importing data. And that is to import an image as data. So you can import data from a file, but you can do that and actually import an image that way as well. So see if it brings up my, yeah, so I'm going to import data, wizard. That's not exactly the right one. Where is the right one? I need to update my version of MATLAB so I have it exactly the way it is in the book. I haven't done that yet. Should though. But there are other ways to import images. It works just as well just to bring it in by loading it, but either way. Okay, so what we really want to get into though is starting to create our images, create some images using some pretty cool programming. And those are all in the examples here. We do one. Let's see. We do the Mandelbrot. Is that the only one they do? Then they do animations and movies. Okay. Mandelbrot movie. Okay, so yeah, let's do example 14.1 and teach you how to build what is called a fractal. So the idea of the fractal is it's a recursive mathematical function, which means it's a mathematical function that calls on itself and kind of uses itself to build its own information. It's a mathematical kind of curiosity, but also it's found a lot of use in lots of different scientific fields, including weather prediction and other kind of randomly determined chaotic systems. If you look up fractals online, you'll find, let's see, what am I on? Here it is. So if we look up fractals here, you'll find all kinds of cool images, and they're always kind of repetitive, like the same image inside of the same image, and that is the idea. If you zoom in on any one of these images, you'll find the same image that you started with, because each image is built on itself. It's built of the same thing over and over and over again, getting bigger and bigger and bigger. It's a repetitive, more recursive is a better way to say it. Recursive is built within itself. But it always has these kind of strange symmetries in it. You could almost call them asymmetric symmetries. But they're always in this recursive nature over and over and over again. And you get the very interesting stuff. Now, one of the very important things of this is fractals play a role in antennas. So here is an example of a fractal antenna. You may have seen these before on tops of buildings or on tops of houses, but what you haven't seen is the fractal antenna inside of your cell phone. That's the fractal antenna inside of your cell phone, or it's similar to that. Here's another image of a fractal antenna inside of a cell phone. It's this chip right here. These fractal antennas allow us to have a very efficient and very effective antenna on something the size of a chip, a microchip. Where normally this antenna, instead of this antenna being 1 inch square or smaller, this antenna would usually have to be 6 inches long, like the old cell phones that had the big antennas you had to pull out. Or whatever. So, but the idea is, while the idea is scientifically a little bit beyond this class, the mathematics can be handled by MATLAB quite easily. It's not terribly difficult to put one of these things in MATLAB. So that's what we're going to do next here. We're going to put one of these into MATLAB and show the imagery using some of these ideas that we've got. So let's start. Let's do example 14.1 with and create our own complex image here. So they give us a lot of background and they do a lot of math in the beginning. What all they're really showing us is that they have this function that they're starting with, this mathematical equation. And then they plug the mathematical equation into itself. And they do that over and over and over and over again to create this fractal interaction. So we're going to start off, it actually starts on page 554. We're going to define a thing called iterations. We're going to use loops in this. So this is something that we've done. This variable called iterations is going to equal 80. That's going to tell us how many times we're going to do this. And then we're going to define a grid size, grid underscore size, to be 500. We're going to use that variable later as well. There we go. And we're now going to create a mesh grid. remember what mesh grid does is it creates an array of numbers in multiple dimensions, depending on how you've defined things. So this mesh grid is going to be called, we're going to have x comma y. We're going to put the mesh grid into those variables, and it's going to be made using the mesh grid function. And the mesh grid function, we're going to go linearly spaced numbers using the linspace function. So we're going to go linear spaced numbers between negative 1.5 and the grid size. Remember, the grid size is 500, so we're going from negative 1.5 to the grid size in steps of 1. No, we're going to go from negative 1.5 to 1, sorry. And we're going to have 500 in between, which is the shape of the grid size. There we go. That's what I wanted to say. The size of the grid size. So what that command does, the linspace command, is it creates an array for x that's going to go from negative 1.5 to 1 with 500 points, because that's the grid size. And then the y is going to be the same. It's going to be a linspace and it's also going to go from negative 1.5 to 1, but it's going to go to 1.5. So it's going to go from negative to 1.5 all the way to 1.5 instead of 1, and also in the size of grid size. It's called advanced graphics. So that's our linspace. If we don't suppress it, it's going to make a huge matrix for us to mess with, so we'll suppress it. And we can see that x and y become 500 by 500 matrices there. So they're pretty big. Definitely want to suppress that. Just going to open it up. If you open this up here, you'll see that it just makes this grid of numbers that goes from negative 1.5, the x one goes from negative 1.5 all the way up to 1 in 2 dimensions. Let's see if I can get it to go all the way up to negative. So we're all the way up to 1. There we go. In this 2-dimensional matrix. So that's what the linspace does. Okay, now we've made these big matrices and everything else. Now we're going to use them with this function. This is the function that we're going to use over and over again. C equals x plus I times y. Right there. So we're going to create a matrix called C that is x plus I times y, where x and y are the mesh grids we just built. So essentially it's just doing this thing over and over and over again. Okay. Then we need to create a matrix we're going to call Z, and it's going to just be filled with zeros. And it's going to be the size of x. So zeros, size, x, right there. So we're going to create a z that's also a 500 by 500 number. So now we've got an x, and y, and a z. And then we're going to map. We're going to define a thing called map. And it's going to be equal to zeros, also size x. So it's creating one more 500 by 500 matrix called map. We're making all these matrices now, and now we're going to put in our for loop. Okay, so we're going to do this mathematical calculation over and over again within itself. So let's take a look at what's going to happen. So we're going to go 4k from equals 1 to iterations, so 1 to 80 in this case. So we're going to go through this loop 80 times, from 1 to 80, right? And the first thing that we're going to do in this loop is we're going to let Z, which is this empty matrix that we made, it's a matrix full of zeros, right? We're going to take this empty matrix and we're going to let it equal itself, Z squared, we have to dot square it, right? So Z dot squared. And then we're going to add to it our matrix C, which is something we did with x and y, right? So we add to it z, or c, which is the actual function. See, plus c. So z equals z squared plus c. And that is actually the what we call the recursion. So that's the thing that occurred. That's the thing within itself, essentially. So we go ahead and we put that in there. The next thing we're going to do is we're going to define a thing called A. We're going to let that equal find where the absolute value of z. So we're looking for something where the absolute value of z is greater than the square root of 5. Now you don't need to know all the details of what's going on here. I'll try to explain it a little bit as I go. But you don't need to remember them all. It's not what we're trying to teach you here. So we're defining this thing called A, which is where we're going to find where a number in z ends up being greater than the square root of 5. And we just define the z by letting it equal itself squared plus c, right? It seems weird to let something equal itself squared, but that's the recursion. We've plugged z into itself. And so when it does that, it's like building on itself or building within itself every time. And then we'll let map at that point, map at the index A equal k. Now what was k? K was the value that we have going through the loop. So whatever time we go through the loop, k will be inserted into A, will be inserted into map at the index A. And that's the end of our loop right there. So we'll end it. Oh crap, square root. So whenever you make a mistake like this, you have to copy this whole thing, paste it down here, and then fix this stupid thing, square root, and then run it again. So I've run my loop, and it is now made, it's made z down here into what it needs to be. It's made A, we now have A, and look how big A is, 240,596, 240,000 by 1, double, totally crazy, complex numbers. And then the last thing we want to do is create an image. So we're going to make a figure. We're going to put this in figure 1. We're going to image our map matrix that we made. And then we're going to use, let's see what we've got so far. That's what we've got so far. And then we're going to use jet color map. So color map jet. See how it comes out. And this is not a very good window size for this, so I'm going to change it a little bit. I'm just going to zoom in on this. And we'll zoom again. But this is the Mandelbrot. Man, this is not very well mapped. I don't like it. It is the right thing. The Mandelbrot image does look like, the Mandelbrot fractal does look like this. There's a better representation of it, but it's very pixelated. But you can see that it's things within things. The Mandelbrot kind of looks like, almost like a heart-shaped thing that keeps rebuilding on itself. And it builds on itself outward as well. These little things poking out here are the same kinds of things. And you can get more and more, resolution by creating bigger and bigger matrices to put these numbers into, so that you can get and smaller numbers to calculate from. Back here, when we created our mesh grid with these lens spaces, we created a mesh grid between -1.5 and 1 with 500 points in between. And if you did more points in between those, you would get higher resolution. And in fact, that's kind of what they do a little bit of that with programming here. as well. Let's take a look at, no, I don't want to go into that. It's too complicated to get into that. However, there are many other, infinitely many other things that you can do with this. So the way to change it is to change what goes on in two different places. First of all, here in the C, back here at C, this is a function that gets plugged in, and you can change that. You can change it by putting in a 2 times x or something else. You can change these things in here, but you can also change the z here. Instead of z squared, you can do z cubed. You can do a square root. You can make functions essentially, and it changes the function that is making the fractal, and it will change the nature of the fractal overall. And they show many of these different fractals as we go through this chapter. Well, they only show the Mandelbrot at the beginning, in the middle of the chapter. But as you get to the end of the chapter, in the homework, they talk about many more of these fractals and the functions that they make, that they're made from. So I don't have a homework assignment for this one yet, but we'll get one. I'm not feeling well again, so I'm going to leave for a few minutes, and then we'll come back and talk about what we want to do for this rest of this chapter. Okay, sorry for that. Just so you know, I'm not sick with something that's contagious, so you don't have to be worried that you're going to get sick. It's a condition I have. Can't be helped. Anyway, so for this section, for this chapter, they go into also what they call figure handles and axis handles. Not something I want to get into, but they also get into animation and making movies. I'm not entirely sure I want to get into those either because we're not going to use them for our final project. Mostly I want to just give you the stuff that you need to finish our final project. Which really means we need to get into the next chapter, which is the graphical user interfaces. So what I'm going to do is I'm going to make an assignment. It's not up yet, but I'm going to make an assignment for you guys that it's going to involve loading images and using images in MATLAB within programs. I'll give you a couple of, maybe one or two things where you're using a fractal as well. You make a fractal just because they're fun. But mostly I'm going to give you I'm going to give you a couple of things where you bring an image into a program and display the image somehow. Because that is something that you can use for our final project. And we're going to end class a little early today just because we don't have anything else really to get into and because I'm not feeling all that well. But look for that homework later today. I'll try to get it up as soon as possible. And we will end at this point. Next, today is the 19th, so we have 1, 2, 3 more weeks of class. Next week we will talk about graphical user interfaces, and then the 2 weeks after that we'll do our final project. The final project is going to involve a program for a card game that you're going to get. You're going to get the program mostly done. Your job will be to figure out what the program does and try to fix some parts of it that need to be fixed. And so it's in some ways it's harder than it sounds. In some way it's not as hard as it sounds. But it's an important thing to learn how to do, to look at somebody else's programming, figure out what it does, and then work on it, try to make it better. So we'll get started on that in 2 weeks. Next week will be graphical user interfaces. So we will see you then. Have a good week. And yeah, that's good. Okay. 7 o'clock tomorrow morning here.